Hello everyone, welcome to the next tutorial. In this tutorial, we are going to learn about source transformation. Okay, so source transformation is basically a technique. So it is basically a technique that is used to simplify various kinds of electrical circuits. Okay, so in this case, like what we do is we convert a voltage source to a current source and vice versa. For example, let's say we have a voltage source Vs and it has an internal resistance Rs. So it can be converted into a current source I of S with a resistance R of S in parallel with this particular current source. The value of the Is will be equal to Vs by Rs. Similarly, this particular current source can be converted as a voltage source in parallel with the resistance. The value of the voltage source Vs will be equal to Is into Rs. Okay. So one more thing which I forgot to tell you in the previous tutorial is that for your ideal current source, the value of internal resistance R, internal resistance, or your Rs is your infinite. Okay. So let's solve a problem. So in this problem, we need to find the value of current I, which is flowing from 4 ohm resistance. So find the value of I, okay, in this particular electrical circuit. Let's use source transformation over here. So as you can see, this particular 5 amperes and 2 ohm resistor are connected in parallel. Okay, so they can be converted into a voltage source with a series resistance across connected to it. Okay, series resistance. So the value of the voltage source V will be equal to this particular current I into this particular resistance R, which is 5 into 2, which is equal to your 10 volts. Okay, so it means that this particular electrical circuit can be re-simplified as, like, this will be the voltage source 10 volt. Okay, so this will be 2 ohms, and okay, so this will be the current source of 2 amperes. Okay, which is flowing in this direction of 2 amperes, and this is 4 ohm resistor. Since in this particular electrical circuit, we can see that the 10 volt and 4 volt voltage sources are acting in opposite direction. So the net voltage in this particular circuit will be equal to 10 minus 4, which is equal to 6 volts. Okay, and also since the voltage source and the resistors are connected in series, so we can again apply the source transformation technique to convert it into a current source in parallel with a resistance. So the value of the current I will be equal to the voltage, net voltage, which is 10 minus 4, which is 6 volt, divided by your resistance, which is 2, which is equal to, so the I will be equal to 3 amperes. Okay, so we can re-simplify this particular electrical circuit as, so this will be the simplified version of this particular electrical circuit. Okay, so this will be equal to your 3 amperes in parallel with a 2 ohm resistor. This will be the current source of 2 amperes, and this will be 4 ohm resistor. Okay, so in order to find the current in the 4 ohm resistor branch, we can just simply apply the current division principle. So I will be equal to the total current, since these two currents are flowing in the same direction. Okay, so we can add them. Okay, so the total current will be 3 plus 2, which is your 5 amperes into 2, okay, upon 2 plus 4. So this will be equal to your 5 over 2 upon 6. So I will be equal to 1.67 amperes. So the current that is flowing from 4 ohm resistor will be equal to 1.67 amperes. Okay, so let's solve the second problem. Okay, so in this problem we need to find the value of Is. Okay, let's first mark the nodes in this particular electrical circuit. So this is your node A, this is B, and this is the reference node C, and the voltage across this particular reference node will be equal to 0 volts. Okay, so in this particular electrical circuit, you can clearly see that 4 volt voltage source is in parallel with 2 ohm resistor and 12 ampere current source. It means that the voltage across the node A will be equal to 4 minus 0, which is equal to 4 volts. Okay. Similarly, the voltage across node B will be equal to 16 volts. Okay. So it means that Vx will be equal to Va minus Vb, which is equal to 4 minus 16 is equal to minus 12 volts. So Vx will be equal to minus 12 volt. Okay. Also, we can also find the value of the current which is flowing from this particular 4 ohm resistor, which will be equal to, according to Ohm's law, we can say that the current in 4 ohm resistor will be equal to the voltage across it, which is equal to minus 12 volt divided by the resistance, which is 4. So the value of the current will be equal to minus 3 amperes. Okay. Similarly, in case of 2 ohm resistor, we can clearly see that the current flowing from 2 ohm resistor will be equal to 16 divided by your 2, which is equal to 8 amperes. Okay. So the current always flows from the positive terminal towards the negative terminal. So this will be the direction of minus 3 ampere. Okay. And this will be the direction of the current which is flowing from 2 ohm resistor, which is 8 amperes. Okay. Also, we can see that like the value of the dependent current source is equal to 4 times of Vx. It means that the current that is flowing from in this branch will be equal to 4 into minus 12, which is equal to minus 48 amperes. Okay. So, which will be equal to minus 48 amperes. Okay. So, in order to find the value of Is, we can clearly apply KCL in this particular node B. Okay. So what we can see is like after applying KCL, so how we can apply KCL? So sum of currents entering the node, entering that particular node, which is B, is equal to sum of the currents leaving that node. Okay. So it means that I of S plus minus 3 is equal to 8 plus 48, which is equal to, so Is will be equal to 59 amperes. So I hope it is clear how we are approaching this particular problem. Okay. So that's all for today, guys. I will see you in the next tutorial. Thank you.